Hello, everyone. I'm Zebin from the Distributed Query Execution team at Starburst. This is the Project Tardigrade presentation. I'm going to start by going over the motivation of Project Tardigrade and how we design and implement it. After that, Corey from BlueCat, one of the early adopters of Project Tardigrade in Trino, is going to talk about their experience. Trino was originally designed as an interactive analytics engine. It provides ANSI SQL support, amazing processing speed, ability to query from different data sources, plus no vendor locking. After seeing the merit of a unified engine for both interactive and batch workloads, it also quickly got popular as an ELT, ETL engine in the industry. In practice, though, insufficient support for long-running queries and memory-intensive queries has been the major pain points that prevent users from adopting Trino at larger scale. Trino is designed for low latency and follows the classic MPP architecture, as the graph shows here. It features in-memory shuffle. Tasks are interconnected, and data is streamed through the task dependency graph with no intermediate checkpointing. The all-or-nothing architecture makes it hard to recover from failures, leading to huge variance of data landing time for long-running queries. With streaming shuffle, Trino requires processing of all partitions of a stage to happen all at once. Therefore, Trino will not be able to execute huge joins aggregations if the cluster does not have enough memory to hold the hash tables. Also, with the original architecture, it's really hard to apply optimization techniques like adaptive query execution, speculative execution, and skew handling, etc. So Project Tardigrade introduces a new execution paradigm into Trino. It adds 2 levels of fault tolerance. The first one is query level. By maintaining a deduplication buffer on the coordinator, Trino supports auto restart of a full query in case of transient failures. This enables auto failure recovery for interactive and short-running batch workloads without the need for users to intervene. So task level retry is supported via storing intermediate data produced by tasks to external storage and plus the deduplication buffer. This allows restart of a single task in case of failure, and therefore providing granular failure recovery. We have implemented a fault-tolerant stage scheduler to guarantee the determinacy, restartability, and atomicity of tasks. With fault tolerance built into Trino, long-running queries can enjoy stable and predictable landing time. Buffering intermediate results makes it possible to execute tasks iteratively, and we are no longer constrained by the size of the cluster to configure the number of partitions. This greatly reduces the memory pressure of large queries, as now we can process a subset of data at a time. We have implemented a lot of optimizations in resource management into tardigrade mode, including adaptive sizing for intermediate tasks, memory-aware bean packing, exclusive node allocation for high memory tasks, memory overcommitment, and there is much more to come. Auto-scaling, spot instance support, heterogeneous node scheduling. Now we can execute memory-intensive queries without the need of expanding a cluster, and this significantly lowers the cost of operation. For exchange spooling, currently we have implemented a file system-based approach supporting AWS Ad3 as well as Ad3 compatible systems. The implementation takes full advantage of Ad3 asynchronous APIs to overlap computation and I/O, and performs parallel reads and writes in parts to maximize throughput. We also opportunistically coalesce split partition files when they are too small or large. We plan to add support for Azure and GCP in Trino soon. In the future, we envision to build a distributed buffering service for Starburst Galaxy, our serverless SQL offering on the cloud, which will take advantage of write-ahead buffers that aggregate data belonging to the same partition, backed by a hierarchy of storage tiers. Stay tuned. In summary, featuring fault tolerance and flexible scheduling, Project Tardigrade greatly improves Trino support for long-running and memory-intensive queries, making Trino a best-in-class ETL engine. It also opens the opportunity to take advantage of spot instances as well as auto-scaling, which will drastically improve Trino's price-performance ratio on the cloud.
Now let's do a quick demo on Project Tardigrade. So this is a Trino cluster with 3 workers deployed on AWS EKS. Now we execute tpchq2 on scale factor of 1000. While the query is being executed, we want to kill one of the workers. So as you can see, while the worker is being killed, the query is still in progress and does not fail. So now we only have 2 workers, but the query is still running. If we look at the query UI, we can see that, okay, we have 4 tasks failed, but they all got properly retried and successfully finished. And now we get all the results. So this demonstrates the fault tolerance of Trino with Project Tardigrade enabled.
The next, Corey, the floor is yours.
Awesome. So I'm super excited to be here. I'm very excited to talk about Project Tardigrade at BlueCat. And now you have a good understanding with the demo of how it operates. Let's talk about our example with BlueCat, how we were able to use this for fault tolerance, elasticity, and cost reduction. So as we're diving into this, I just want to give you some context of what BlueCat is and what we do and how we're using Trino today. So BlueCat is a DDI company. We work in DNS, DHCP, and IPAM. Essentially, in a nutshell, what I tell people is we're enterprise, Fortune 500 focused, and we secure networks and make them operational. So with that said, we are very data focused in securing networks, and we built a data platform, and it looks on a high level like this. We stream in the data, we sync it, we use Trino exclusively for all our queries, and then this is exposed through reporting via ad hoc or through analysis via an analyst in the company or research team. So for those who are very nitpicky and would like more details of what the technical aspect of this looks like, it's essentially this. So we push into Apache Pulsar, Flink picks it up, pushes it to S3 and Parquet. Trino, as I mentioned, handles exclusively all our queries. And then Airflow handles the scheduling of anything that's long-running batch that would use Trino. And we're in AWS, it's Kubernetes, and we're deployed via Helm/Helm files. Internally, the project's called Shepherd because it's herding of all the data in one direction. So we have both patterns observed in the clusters we have. So we have ad hoc mixed with long-running queries. So we might have someone in like our care team using it for analysis, and those are typically under 5 minutes or less. But we also do through Airflow, Apache Airflow, have long-running queries. So it's like those are aggregated kind of materialized view generation, and those almost always exceed 5 minutes. So we have been using Trino for quite some time, and it's always been a focus of cost reduction on a larger range of data and quicker. So we have progressed from the Hive connector to different file formats to compression. We wrote our own in-house compactor before switching over to Iceberg. We've even flattened down some of our data. We're really trying to look at accelerating completion time and just having reproducible expected time. So that brings us to where we are today, which was introducing something called Kubernetes HPA. So if you're not familiar with Kubernetes, the high overview is you have your pods on the bottom, as you see. Those are like Docker containers, and you scale those on something called HPA. Essentially, if a threshold is met, say CPU utilization is met, we add more pods. Or if the threshold is not met, we decrease the number of pods. Those pods in our case would be Trino workers. So we want to expand that up or down. Also, there's a concept of cluster autoscaler, which is how many boxes are within the cluster. And this just allows us total elasticity. So not only do the Trino pods scale up, but also the entire cluster can be scaling up. So our thinking was Trino meets Kubernetes scaling. It's just super fast. It's going to be on-demand, infinite scalability. We remove any sort of application retry logic, and there's no application scaling. So as an example, prior to this, we were using Apache Airflow before we kick off these large running batch jobs to tell the cluster to scale up. And then at the end of the job, we could tell the cluster to scale down. But this is really complex logic, because what happens if you have multiple jobs and job 1 said scale up, job 2 said scale down. And my devs just don't want anything to do with this, because when you're in the Kubernetes world, that's all infrastructure problem. The cluster should be aware of when to scale up and scale down, not the devs, not the application code. So we decided to roll out HPA, and it was like, oh, not so fast. So we had fault tolerance issues. Trino very promptly told us when we rolled out HPA, like, this task is non-existent. So for those not familiar have seen this error, maybe you don't have long running, or maybe you've just never bumped into this error. The scenarios of how this kind of happens looks like this. We have these pods, as you see in the bottom. Those are Trino workers. Let's say for any particular reason, no particular reason, for any reason, a pod dies. That means whatever was running there is gone. That task is going to fail. The query is going to fail. In our case, for HPA, we are scaling up those workers. So you might have something like a long running query followed by some very small ones. So you scale from 1 pod to 5. So 1 worker to 5 workers. That large batch running process finishes, and then you could have a smaller batch running process come in. That could be on pod 5, but we just killed it because CPU threshold might have been lower than what it was. So we decreased the cluster, and that just killed things. Other things is, as I said, the cluster itself is expanding. So a whole node, EC2 instance in our case, could have died, could have been downscaled, could have had maintenance for any reason. That would kill anything on Trino side running within that. Once again, fault tolerance issues. So as I mentioned, maintenance, outage, any impact, network connectivity would fail us. So Project Tardigrade to the rescue. That is why we're all here. So we had the query retries, which was our initial step on that. We had enabled that. That basically allowed us to disable the, or not heavily rely on the Airflow, Apache Airflow retry mechanism, which we had been using. It also just got the team comfortable with the fact that they could now run a long running job that they had, go get their coffee, come back, and it would just be finished. Even though you have like the fact that maybe the query failed and had to rerun the whole query, it's not ideal, but it was a starting point for us. Then the task retries came, which is the more ideal, as we had heard. This is just going to rerun the individual task component that failed instead of refreshing the entire, going all the way back to the beginning of the query and restarting the entire query. So Project Tardigrade really came in to save our bacon. So for us, it was just really basic, straightforward configuration. Like the documentation goes into more of the precise settings that you wanted to configure, but we essentially just enabled the retry policy to task. We did have to set the memory limit to essentially infinite. And this is just because of our scenario. The cluster is entirely elastic. So we could have the cluster with 100 gigs of memory initially, and then it could be 1 terabyte of memory, and then it could go back down to 100. So the way that we're getting around that is we're just managing the memory by the per node setting, and we're just at the moment setting the max cluster utilization memory limit to like a very large setting. And then we are using the S3 configuration, so we had to enable that. So everyone loves graphs. The graph doesn't look like much because everything's actually working flawlessly. So let me jump into it. What you're seeing here is actually the cluster is, from the infrastructure perspective, scaling up and scaling down. And the reason why it's not super exciting is because from Trino's perspective, everything is flawlessly executing and finishing, and the query is being delivered. From the infrastructure side, this is the view I see. everything worked as expected. It scaled up when the utilization was met. It scaled down when the utilization wasn't there. So nothing super exciting of like task retry or query retry or fail versus versus. Like from my point, it's the infrastructure. I don't actually care because everything worked as expected. You would know if it wasn't working as expected if we saw like a bunch of this ramp up, a bunch of this failure, but these are just batches and we scale up. We accomplish everything completes, there is nothing that fails, and we just scale everything back down. So from our standpoint, Project Tardigrade really was this better experience and cheaper. It really focused on making our completion time reliable. It allowed the business to have a total elastic compute. And internally, we've really struggled with Trino prior to this project. Everything else in our cluster is under the assumption that it can be killed or died or fault tolerant. It will move, it will be replaced. And Trino was our last hurdle because it was basically in a node group that we had to treat as static in time. This is quite straightforward. If you're a much larger company, you're bare metal and you're just going to provision this and set it and not touch it. But with us, our entire cluster shrinks and grows on the demand of whatever the cluster needs as work comes in. So we couldn't necessarily just scale up. Like we have long running batch stuff that we would like to just scale up to 100 EC2 instances and then scale down like 10 minutes later down to 1. So this solved that. Also, as mentioned, we saw significant cost reduction because our long running batch stuff is able to take advantage of spot instances now. If you're not familiar with the Amazon spot instances, what happens there is you get 2 minutes of notice and then your EC2 instance is going to be. The issue before this project was I might have something running there that's going to well exceed 2 minutes and I have no control of being able to stop that or pause that. I have to finish the query in that time or it's going to be failed query because Amazon's going to show up, kill my instance, I'm going to lose it. You're going to get that task error saying like, hey, 503 timeout because it's not available anymore because Amazon killed it. So now with this, the fact that we have task retries, what happens is the instance can come in, be killed. It's going to move off, just kick off the task again on another box that's running and it's all seamless to us. And we just get to get all the advantages of the cost reduction on the spot instances. So with that said, I think that's everything. Sure, you have plenty of questions. Ask in the chat. I will be available to answer any questions. And I really think this is a game changer to making Trino really cloud native as a first-class citizen.